we talk about fermentation. Fermentation is a process that we use microorganism, the good one, the one we want them to grow, to do the changes in the way that we aim for. It's called fermentation. Microorganisms in general view we can classify into three groups. The pathogenic microorganism, which we don't want them to appear or to grow in the food. The other group is spoilage microorganism. This we also do not want them to grow during the storage of the product because they grow. They don't cause food poisoning, but they cause spoilage of food. Then we lose the food. We have shorter shelf life. We lose the economical value. The other group is the starter coater, or the good one, okay, the one that we want them to grow, to cause, to change the food in a positive way that we want. So in doing fermentation, we want this group to grow and we generate the favorable conditions for them to grow. Right, so the first we discuss about spontaneously fermented sausage ecosystem. Ecosystem means the general flora of microorganism in spontaneously fermented sausage. Spontaneously is kind of like naturally. Like we do fermentation with natural microorganism, with the good one which occur naturally in the food, in the ingredients, okay, in the materials. We don't add intentionally the microorganism, the starter coater, but this we use the natural one. So how to make? First we do mixing of minced meat and fatty tissue with curing agent, some sugar for example, as a source of substrate for the bacteria to use, and spices to improve the sensorial quality for example. And then we do stuffing into the casing of sausage, là vỏ bọc, the packaging outside of the sausage. Stuffing means we just introduce into the casing or into package, and then the next step we do ripening together with aging, a number of days for fermentation, and then other day we call aging, and these together we call ripening. Ripening to have fermentation, to have biochemical changes, so to have the properties that we want for our products. So this is a general way to do fermented sausage. Include a traditional meat product of Vietnam. I already told you in previous chapter. Nem chua is actually made this way. This is making with natural fermentation. So the lactic acid bacteria in the meat, in the spices, in the leaf. For example, in nem chua they use guava leaf, for example, and the leaf also carry a number of lactic acid bacteria which do the job, do the fermentation. It's called natural fermentation. So in the whole world, in many countries, there are variation in type and amount of raw material fermentation, drying condition. The differences in raw material in fermentation in dry condition lead to the diversity, standards diversity concerning the dominating microbiota, giving rise to a wide range of products with unique sensorial traits, unique sensorial attributes. So, for example, in Vietnam, we have nem chua, but nem chua from the south of Vietnam doesn't taste the same like nem chua from the center or from the north of Vietnam. Okay, because there are differences in the raw material, differences in fermentation condition, then difference in a bit profile, the difference a bit the microbiota means what are the dominating microorganisms inside which do the job, and then we'll generate a product with not the same flavor, not the same texture, and so on. So in Indonesia, Philippines, Thailand also, they have their own traditional fermented meat products. And then all these products do not taste the same. So when we do fermentation, natural fermentation, there is a shift in microorganism flora, microbiome flora from the beginning to the end of ripening. From beginning, the batter freshly stuffed into casing. Batter, if you remember the term, meat emulsion. At the point that we just stuff into the casing, the microorganisms which dominate include Pseudomonas spoilage microorganism, Enterobacteriaceae family, the microorganism from the intestinal tract. Okay, from beginning, so these are the microorganisms which dominate the system. There is low population of lactic acid bacteria, enterococci, yeast, and mold. Okay, in the beginning, there also may be present of some pathogen like E. coli, Staphylococcus aureus, Listeria monocytogenes. Okay, from beginning, there's some amount of that, and then at the end of ripening, uh, some products like name cure, we do not have drying, but other countries they do fermented product. They also do some drying, so then the water activity is reduced, oxygen is consumed, and then there is a shift in microbiota composition toward the lactic acid bacteria. Beginning, you have many groups dominating with spoilage and some pathogen, and to the end now the richest one is lactic acid bacteria, and the family Micrococcaceae, Enterococci, and some yeast and mold take place. Right. So during fermentation, there's a change in microorganism. The one that survive or the one that can grow in the fermentation condition will grow in number. The other one are inhibited, then reduce in number. So if you remember, we explained somewhere that during fermentation of meat product, at the beginning we have to generate the condition which is favorable for lactic acid bacteria. So you have to lower the air, lower the oxygen, maybe you also add some nitrite. Because nitrite will prevent other microorganisms but do not prevent lactic acid bacteria. And you remove oxygen and so on. And then for the lactic acid bacteria to grow, when the lactic acid bacteria grow, the pH will reduce. When pH reduces to a certain level, it actually inhibit a lot of bacteria, because bacteria, most of them cannot grow at low pH. When the pH is low enough, it actually also inhibit lactic acid bacteria. Inhibit themselves because now the pH is too low, and then you have the product ready for a bit of aging and then for consumption. And after a point, when you have spoilage, when it starts spoilage, normally the yeast will grow. The mold will grow if there is oxygen, but no oxygen, then the yeast grow, because yeast can grow at low pH. If you remember chapter 5, yeast grow will digest acid and then will increase pH. When the pH is increased, then a lot of other bacteria can also grow. This is the starting point of spoilage. Okay, this is how more or less the profile of fermented meat product during fermentation and during aging, during storage, consumption. Now we can look at this to see what happened with some conversion of components. For example, this is a microorganism which do the fermentation job. The ATP in the muscle, glycogen in the muscle can be hydrolyzed, can be broken down. This is broken down into simple sugar. This is hydrolyzed into ribose. And these are used as a substrate for lactic acid bacteria, for example, to produce organic acid. The main one is lactic acid. But some other microorganism he can produce some certain amount of acetic acid, butyric acid, and so on, depending on the microbiota here. And then here you have proteins. Protein is also hydrolyzed by proteases in the raw material or contaminated from microorganism, hydrolyzed into peptide and amino acid. And then these can be the substrate for microorganism to use to develop, produce flavor, volatiles, which is also good for sensorial quality of the product. Some amino acids can be converted into biogenic amide. This one is negative. We don't want. Okay. Here the triglyceride, the fat, phospholipid is polar lipid. Triglyceride is neutral lipid, and this is polar lipid, also lipid, and this can be also hydrolyzed by the enzyme with hydrolyze the lipids. And then we have free fatty acids, and then free fatty acid can be oxidized either by oxygen, residue of oxygen in the system, or can be hydrolyzed, can be oxidized somehow by the activity of microorganism. So the fat will be oxidized, and this one is actually negative, also not good. This one is one that we want. Okay, also this one to reduce pH, to make the texture, to also contribute to flavor, because organic acids give you flavor, the taste, and this one will give flavor, aroma component of the product, also good.